Hello everyone, this is chapter 2.3, A4. Today we are going to be talking about rotations. Please make sure that you do copy this down. I will circle everything that you do need to get copied down, so please make sure you have your name, the date. The lesson is 2.3 rotations. Please make sure you copy this down, the learning target, rotating figures in the coordinate plane, the success criteria. By the end of this lesson, we should be able to identify a rotation. We should be able to find the coordinates of a rotated figure around the origin, and then you'll be able to use your coordinates to rotate a figure about the origin. Okay. Press pause when you can to copy all of this down. All right, some definitions that you also need to copy down as well. Please have this copied down in your notes. A rotation or a turn is a transformation in which a figure is rotated about a point. So just to kind of give you an example, if I said I was right here, I was right here, and I wanted to turn 90 degrees counterclockwise, I'm going to explain all of what that means. That means I'm going to turn, a 1/2 step this way. So I would be over here. Counterclockwise is that way. So we're turning around a specific point. So basically what's going to happen in this lesson is you're going to get a coordinate like an X and a Y, and they're going to ask you to rotate something around that point, either to the left, to the right, 180 degrees, which would be over here, or 270 degrees. And we're going to talk all about that, okay? Now, a rotation, again, is a turn, is a transformation in which a figure is rotated around the point, and that point is called the center of rotation. The number of degrees a figure rotates is the angle of rotation. So we've been talking about angles. So if you remember last year, we were talking about angles. And this right here, this would be a 90-degree angle. And if I drew that exact same thing again, this would be good for you guys to copy down as well. So if I drew this, if I drew this way, right, I have a 90-degree angle there, and I have a 90-degree angle there. So if you add both of those together, a 90 plus a 90 would give you 180. So the opposite of this would kind of look like that, okay? So this would be a 180-degree rotation. But we're going to do a lot of practice on this so that you guys can understand how to do this. The angle of rotation. So there are 3 angles of rotation that you can have. I would suggest you press pause right now. Please copy this down, this entire box. You will need this for the rest of this chapter. So please make sure you copy this entire box down, okay? As you are copying this down, or if you've just pressed pause and now you're copying this down, here's some things they need to know. So if we had a clock, right? 12, 1, 2, 3, 4, 5, 6. Clockwise. Clockwise means like it's going like the clock. That means it's going this way. The blue one is going clockwise. It goes to the right. Counterclockwise will be the one that's in black. That means it's going to the left. So just know the difference between clockwise. Clockwise goes like the clock. That's clockwise. Counterclockwise goes opposite of the clock. So counterclockwise and then clockwise. All right. There are 3 different kinds of angle rotations. You have a 90-degree angle rotation. You have a 180-degree rotation. Then you have a 270-degree rotation. This last one, 360, honestly, I shouldn't have put that. That's basically you end up at the same point you just started. So you really don't need that last one, but you need these 3. A 90-degree rotation, a 180-degree rotation, and a 270-degree rotation. Please make sure you copy this down. These rules are also on the board inside the classroom on the chart. If you've also forgotten a little bit about graphs, we have the quadrants right here. We have quadrant 1, quadrant 2, quadrant 3, quadrant 4. I also labeled, we have 90-degree counterclockwise, 90-degree clockwise, 270-degree. You can write those down, and it's going to help you understand doing this, okay? Before you move on, please make sure you have everything copied down on this page so that we can move on to the next question. Just a quick review of what we have been doing in lesson 2.2, finding the coordinates of a figure after we reflect it across the x-axis. So let's remember how we are supposed to do this. First thing, remember you are copying this down. First thing you need to do is please copy down these questions right here. I would, again, suggest you copy them horizontally like this. After that, you want to plug in your formula. So what is the formula for when we go across the x-axis? Also, ladies and gentlemen, by the way, which one is the x-axis? The blue one or the black one? That's correct. It is the blue one. That is the x-axis. That means we are going to be flipping stuff like this, either on this side or on this side, one of these two. So what is the formula for going across the x? Well, the formula is x and negative y, x and negative y. All right. Now, what else do we want to do? Now we want to plug in the numbers into our formula. So we're just going to put parentheses, and it goes like this. A good idea would be for you guys to answer these questions prior to me solving them. So now let's just plug everything in. We got negative 5, negative 4, negative 5, negative 1, negative 2, negative 1, negative 4. 5 stays the same, but I notice I have a double negative, which makes that 4. That stays the same. I have a double negative, which makes that 2. Double negative, which makes that, makes that positive 2. And then the x stays the same, and that's a positive 4. And there you go, ladies and gentlemen. We just found the rules for this problem and solved our question. What I also want you to do is please get a graph piece of paper, and you will be graphing this. I want you to graph the original, this one that's here in yellow in one color, and then I want you to graph your new image in a different color. Okay? Thank you. Let's go on to the next question. Another question, very similar to the last one. First step is to actually write down the question. Again, I would recommend you to write it down horizontally like this. Give yourself some space. Next, you would like to add in the formula for going across the x-axis, and we know that that is going to be x and negative y, x, negative y. I apologize about that. It's the train at school. Y, x, and negative y. Now, we want to put our parentheses. Now we just want to plug everything in. So now we have 2 and 1, 2 and 5, and 4. And our new coordinates are going to be, there we go, that's the first one. All right, last part about this, I do want you guys to graph these. To save yourself some space, you can graph this specific question on the last one, but please use different colors. I'll say that again. I should be able to see different colors if you're going to use the previous graph. Now, one other thing I want to recommend to you guys, graph paper is expensive, so I do not want to see you answering one question per page like this. You know, if you were draw a line, you're like, Mr. Guru, I'm doing one question per page. Do not do that. Use only the numbers that you need. So if you take a look at this, the biggest number is 5. So make a graph that goes up to 5. 1, 2, 3, 4, 5. All right, and then you wouldn't need to create the whole thing, just up to 5, okay? So take a look, it went from that big old graph to now something a lot smaller. You can fit it in the corner somewhere. All right, thank you. Let's go on to the next question. First things first, we want to see if we can find out what is a rotation, what is a slide, what is a translation. So it says tell whether the dashed figure, so this figure right here, by the way, there's nothing to copy down on this question, so just please listen and understand. This dashed figure right here, tell if this is a rotation of the solid figure about the origin. If so, give the angle of rotation and the direction. So one thing we need to know is the easiest one to describe is a rotation that is 180 degrees. So 180 degrees is basically the opposite of something. So if you are, let's say you're standing this way and you are facing that way, right? You're looking that way. 180 degree rotation would be you this way and facing that way. It's the complete opposite. So the complete opposite of this problem should look exactly like, well, an opposite of a problem. So this one is a rotation, but we're going to learn how to do the math. So the math on this one is the same. What I want you guys to do right now is now we're going to write this down. I'm going to label these points right here. That's A, that's B, and that's C. First thing we want to do is label our points, A, B, and C. Point A is -1 and 1. Point B is -1 and 2. And point C is -3 and 1. All right, next thing we want to do is we want to add in our formula. So what is the formula for a 180 degree rotation? Well, the formula is like this. You have -x and -y. Now, if we go back to this example that I did right here, this example that we did right here, 180 degrees is the easiest one to solve because it's the complete opposite. So before I even go, I can tell you the complete opposite. What is the opposite of -1? So it's going to be 1. What is the opposite of +1? It's going to be -1. So that's what our answer is going to look like. But I do want you guys to show the math, so this is what we're going to do. We're going to plug in our formula. So let's put our parentheses. And do that for each one. Now we just got to plug in our numbers. So we have -1 and 1, -1 and 2, and then -3 and 1. All right, now let's just solve. Looks like I have a double negative, so my new coordinate is 1. This one's going to be -1. Notice I already got that. Perfect. Now I have +1 and -2. Oops. And then this one right here is going to be 3 and -1. So notice, ladies and gentlemen, when you do a 180 degree rotation, it is completely the opposite. So what is the opposite of -1? It's +1. What's the opposite of 2? -2. What is the opposite of -3? Well, that's 3. And what's the opposite of 1? That is going to be -1. And that is how we get our answers. But what I want you guys to do is I want you to actually show your work by plugging in the formula, plugging in your parentheses. It will help you in the long run. All right? Let's check out the next one. Tell whether the dashed figure is a rotation of the solid figure. Well, there's nothing to write down for this one. I'll tell you right now that this one is not a rotation. This one's actually, does anybody know? This one is a slide. Why is it a slide? Because that's exactly what it did. It slid over this way. Rotations usually change shapes. So if you would have done another rotation, it might have looked like this. A 180 degree rotation would have looked something like this. Oops. And then we would have talked about a 270 degree rotation. That would have looked like something different as well. All right, let's do an actual problem showing the math. So first things first, you do need to have a graph for this problem, ladies and gentlemen. So you do need to draw a graph. So first things first, let's plug in our numbers. So let me draw some straight lines really quick. Again, ladies and gentlemen, please remember that you should be saving graph paper, not wasting graph paper. So please make sure you use as little graph paper as possible. All right, -4 and 1. So we have -4 and 1, -2 and 2, and then -1 and 1. So first thing we need to do is we need to plot all of these numbers. Also, please make sure you press pause whenever you can so they can answer these questions correctly. So -4 and 1. Then you have -2 and 2. And then -1 and 1. So we're looking at this shape. It looks like this. Let's connect all the lines. Please remember, I said you do need to draw this on graph paper. So please make sure you draw this on graph paper. Good. And then the question says we want to do a 270-degree clockwise rotation about the origin. So what is the formula for a clockwise rotation? So it's going to look like this. Once you wrote down your coordinates, we just got to plug in our formula. And our formula is like this: -y and x. All right, now let's plug in our parentheses. All right, so let's remember, we have to put our y in this spot. So what is our y? I'm going to highlight these so you guys can tell the difference. So there's y, 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 y. Here's x, 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 and x. All right, now we just got to plug in our stuff. So what is our y? That's going to be 1. What is our x? That's -4. What is our y? That's 2. What's our x? That's -2. And then what's our y? That's 1. And what's our x? That is -1. So what are my new coordinates? Let's just solve the problem now. So I have -1 and -4. I now have -2 and -2. And then I have -1 and -1. All right, now we just got to plot this in. Remember I said we want to use a different color. So we have -1 and -4. 1, 2, 3, 4. And now we have -2 and -2. 1. Oops. That's right there. And then -1 and 1. There we go. So now if we just connect our shape, it's supposed to look like this. This is a 270-degree rotation that is clockwise. Okay. So this is what your work should look like for, this is example number 3. Let's move on to the next question. Here we go. We have these points and we want to do a 90-degree counterclockwise rotation about the origin. Are these the same numbers? Let's say -4, 1, -1, 1. So now we want to do a 90-degree counterclockwise. All right, let's do it again. Make sure you have it on graph paper. You're going to notice something special about this specific question. All right, so let's draw our graph again. Oops. And now let's plot some points in. We have -4 and 1, -2 and 2, and then -1 and 1. And what is the formula for a 90-degree counterclockwise? Well, that's going to be -y and x, -y and x, -y and x. If you guys notice anything, this is very similar to the last question. Let's plot in our points. 1, 2, 3, 4. Now if we connect these, there we go. Let's plot in our formula. Let's plug in our numbers. So our y needs to go there. Here's our x. Our y needs to go there. There's our x. And then our y needs to go there, and there's our x. All right, let's plot these new points that we have. We have -1 and -4, -2 and -2, -1 and -1. If you guys already caught the flow, this is going to be the exact same thing as our last question. A 90-degree counterclockwise is the exact same thing as a 270 degrees clockwise. I don't know if you guys caught that on the graph, but now you will. Now let's just plug it in. We got -1, -4, 1, 2, 3, 4, -2 and 2, and then -1 and 1. So if you did draw this, it would look just like this. All right, let's do another question. You guys are about to walk up the stairs. Same points. Let's draw our graph. So here we go. Make sure you draw a different graph, ladies and gentlemen. I'm just going to do this like this, since we already have it. Please draw another graph to have it done. And this time we are going to do a 180-degree rotation. So what is the formula for a 180-degree rotation? Well, that's going to be negative x, negative y. Now let's plug in our formulas, our parentheses. It should look like this. All right, now let's plug everything in. And now if we solve, notice we have a double negative here, so that makes that 4 and negative 1, 2 and negative 2, and then 1 and negative 1. Now we just need to plot these in. So let's plot in our original coordinates. So we have negative 4 and 1, negative 2 and 2, and 1. So this is what this looks like. This is the original one. Remember I said I want you guys to please use different colors when we do this. So now let's just plug in our next one. So now we have 4 and negative 1, 3, 4. We have 2 and negative 2, and then we have 1 and negative 1. So this is what our new shape should look like. And that, ladies and gentlemen, is a 180-degree rotation about the origin. Let's try another one. I think it's the same question. Oh, yeah, we did that one. All right, same question. This time we just want to do a 90-degree clockwise rotation. What is the formula for a 90-degree clockwise? Well, that's y and negative x. All right, let's try this one out. Again, what you need to do is draw your coordinates. Oops, let's draw that better. Negative 4 and 1. It's negative 2 and 2. And then you have negative 1 and 1. Let's plot those in. I can hear you guys coming up the stairs. Let's see if we can finish this really quick. What is the formula for a 180-degree rotation? Negative x. Oh, sorry, it's 90-degree clockwise. It's y, negative x, y, negative x, y, and negative x. Let's plot in our parentheses. Now let's plug it in. We have 1 here, negative 4 here, 2 here, negative 2 here, 1 here, negative 1 here. So we got 1, and that's a double negative, that's 4. We have 2 and a positive 2, and then we have 1 and a positive 1. Now we just got to plot these in. 1 and 4 is right there, 2 and 2 is right there, and 1 and 1 is right there. So ladies and gentlemen, this is how you would do the rotations. Please make sure you follow the rules. Step 1 is to write down your coordinates. Step 2 is to write down your formula. Please write this down. Step 3, you want to plug in your parentheses. And step 4 is you want to plug in numbers and solve. All right, try your best on these questions, and I'll see you guys later. Bye. Have a great day.